We're going to need to do a substitution to integrate this. Let's see what our options are. One option would be u is secant of x, because we have the secant squared in the integral. This, of course, would be u squared. The derivative of secant is secant tangent, and maybe it looks like there's something there, but it's going to be really hard to write this tangent to the 10th power using just this information here. So I'm going to put a question mark on that, and let's look at our other option for u. If we make u tangent of x, then our du, the derivative of tangent, is secant squared. Now this one looks really promising because we have a tangent of x here. This is going to be u to the 10th, and our du is secant squared x dx, which is right here. So I think that that's the one that we're going to use. Let's see what this integral turns into. I'm going to bring the 7/2 out. We can talk about limits in a second. The tangent to the 10th is going to be a u to the 10th power, and the secant squared x dx, the rest of it, is going to be du. In one of the previous videos with the definite integral and a u substitution, we mentioned that these limits here are limits on x. And what we decided to do in that previous video was to just continue writing these limits in terms of x. Then what we did is we integrated, and then we substituted in what we used for our u to get back to the variable x, and then we plugged in our limits. But that's not necessarily the way you have to do this problem. We could change our limits on x to limits on u by saying when x equals 0, u equals, well, u would be the tangent of 0. Tangent is sine over cosine, so we know that that is 0. And if we look at our upper limit, when x equals pi over 4, u is going to be the tangent of pi over 4. And from our unit circle, we know that the tangent of pi over 4 is just 1. So our limits on x going from 0 to pi over 4 actually turned into pretty convenient limits on u going from 0 to 1. Now, since this is a definite integral, we can do this problem without ever talking about an x again. Let's do it. Let's integrate. Multiplying our fractions gives us 7 over 22, and we're going to evaluate u to the 11th between 0 and 1. Using that fundamental theorem of calculus part 2, we plug in our upper limit, we subtract, we plug in our lower limit, and this is pretty easy to simplify. We just get 7 over 22 as the final answer. Okay, that was fun. I'll see you in the next video.